Hello and welcome to a long overdue development log. I hope you have been well. Last time we took a deep dive into networking, discovered that syncing potentially over 9,000 actors, buildings and objects would be near impossible. I found however a solution to syncing only the commands and achieved a synced experience by changing the game logic to be deterministic and by executing the game commands at exactly the same moment on all machines. If you'd like to learn more about this, please check the previous 2 videos I've made about this. All seemed well at the time. However, nothing could have been further from the truth, because with years of slow and scattered development in my sparse free time, without any formal project education, I seem to have unwittingly created a monster. A monster that could be best described as a many-headed hydra, its necks twisted and mangled in a spaghetti-like mess, impossible to comprehend or make heads and tails out of. I am, of course, speaking about my actor class. As the scope of my project slowly grew from fun little static isometric project to moving actors into pathfinding and later complex behavior simulating actors that could also fight, the code kept growing organically without real structured plan. This accumulated into quite a mess of if statements that had all be checked each update. As you can imagine, this made updating the next frame a little slow. This was however not even the biggest problem. No, the big problem was that the code was beginning to be very hard to maintain. Because if I wanted to add a new behavior or change an existing behavior, I would need to spend a lot of time finding where in my tangled mess that behavior was described or could be added without disturbing the rest of all the behaviors. The more complex the actors became, the bigger this problem posed. I did not realize this at the time, but this problem was an ideal candidate for a multi-level state machine. So after doing some research into this, I got convinced this was the way to go, and eventually, after much deliberation, I bit the bullet and created a new branch of my game. Here, I deleted the entire actor class and started with a new one. A class designed with a 3-level state machine from the get-go. Why 3 levels? Well, it's a bit arbitrary, but the actors have to display very specific contextual behavior depending on the task they are executing or the state they are currently in. For instance, what happens after the actor has finished walking to its destination? This is different when the actor is gathering or returning resources, building a building, or attacking an enemy, or just walking from A to B. 3 levels of complexity gives me a nice level of granular control, keeping the implementation per state very neat and tiny. This makes for easy to read code, which is also very fast in executing because it's only a couple of lines. Let me explain this in more detail. In order to make this more clear, an actor can have any of 6 base states at the moment. These include walking A to B, building, gathering, fighting, being idle, and being dead. To take gathering as an example, the base state governs which ground state is active. For gathering, there can be any of 4 ground states. These include walking, being at the resource, returning the resource, and finding alternative for the resource. If we then look at the implementation of being at the resource, there could be 3 substates. These include walking to the working distance from the resource, gathering the resource, and walking back to the center of the tile the actor is currently occupying. Every update tick, the deepest child of the state machine is run. If it's done executing its tasks, the child notifies the actor class and the parent script is run. This will kill the child, and the parent can either spawn a new child or, when all the test is done, repeat the process with its parent and be killed itself. Some scripts just turn the actor to an idle base state when they finish all their tasks. Other scripts, like gathering, are designed to run indefinitely until the task has become impossible to do, and only then will change the base state of the actor to idle. Another way the base state can be changed is by user input or being attacked, of course. I found this an elegant solution to simulate complex behavior without the code getting into a complex and convoluted mess. The actor class is now easy to maintain, and new behavior can easily be introduced by just adding new base, ground and subclasses from templates. As of right now, the functionality of the actor class is on par and even exceeding the functionality from before the redesign, with actors now even being able to flee from an attack. Rewriting everything was a lot of work, and to be honest, it was not as rewarding as writing it the first time around. But it's definitely worth the effort and worth every second I spent on it. It was desperately needed. Not only is my code more easily expandable, also all functionality has been rewritten after 2 or 3 years more programming experience. No doubt new bad habits have formed and haven't found their way into the code, but that's just life. If you like to review the code and changes made, a link to the repository on GitHub will be provided in the description of the video. Here you can also keep updated about the progress I make between devlogs. Now that this extensive rewrite is out of the way, I can finally begin to expand the game again, which will no doubt mean drawing a lot of sprites for all the different units I envision to one day populate my game. For now, I want to thank you for watching all the way to the end. Don't forget to like and subscribe to not miss out on future updates. And I will see you in the next devlog.